Okay, so in this lesson, we're going to be doing section 8.3, and this is the law of sines. So what is the law of sines? Well, if you remember from lesson 8.2, the last lesson, we learned that the trig ratios in a right triangle, the SOHCAHTOA information, and how to find side lengths and angles and stuff like that. But what if I don't have a right triangle? Because the SOHCAHTOA ratios only are for right triangles, but not all triangles are right. So how do I deal with triangles that are not right triangles? We use what's called the law of sines. Okay? The law of sines says for any triangle with side lengths A, B, and C that are opposite angles A, B, and C, the law of sines relates the sine of each angle to the length of the opposite side. So here is how the law of sines works. The sine of angle A divided by side length A is the same as the sine of angle B divided by its opposite side length. And it's the same as angle C, the sine of angle C divided by its side length. This ratio is exactly the same for all of these. Okay, so that means we can use this to help us find angles and side lengths according to this. You will not use all three at the same time. You only use two of the ratios, so it sets up potential proportion at any one particular moment, depending on the information that is given to you. Okay, and so how do I know that I can even use this? When do I know I can use that? The key to this is to use the law of sines. A complete ratio must be you must have the information for a complete ratio. That means you have to have an angle and its opposite side, or be able to find the angle and its opposite side before I can use this thing. Okay, so I need three pieces of information, and usually it falls into this format from your geometry days. I need basically two angles and a side, or side-side angle. Okay, so that's the issues I need. So if I do a side and this angle, you'll see that I created that opposite side ratio, completed ratio. If I do angle, and the side, then this angle and that side will be in our opposites of each other, and we can use that. So the key to this is to make sure that you have a complete ratio. You have to have the information to complete a ratio. If you don't have that, you cannot use law of sines. So here we go. So here's an example. We want to find XZ, this length, to 3 decimal places, and I have this information. You'll notice that I have a complete ratio here and here, angle 77 degrees. This is at side 7, this is 51. Okay, so I have a complete ratio, I have enough information to solve this problem. Because I want to find this side length over here, which we're going to call Y, because it's opposite angle Y. Okay, but to do that, I have to find this angle over here. What is angle Y? Now, even though I was not given angle Y, I kind of was, because I gave you these two angles. And so angle Y has to be 180 degrees minus 77 minus 51. And then we can use our calculator to determine all this value out. 180 minus 77 minus 51. And we get an angle of 52. So this angle up here is 52 degrees. Once I have that, I can use my complete ratio. So the sine of 77 degrees over 7 is equal to the sine of 52 degrees over side length Y. And that's your setup. That ratio, that ratio. Okay. So once I have that, this is what you must do. The next step here is to solve for Y. So you can see here that I have to cross multiply again. Okay. Let me show you the shortcut for this. Notice, normally I would multiply in the diagonal, then I would have to divide by this number here. So what I usually tell students is, as long as there's only one space, there's 4 spaces, if only one space has the Y, you multiply the diagonal that has no variable and then divide by the third value. So multiply this diagonal, because there's no y there, and then divide by the third value. And you get y equals 7 times the sine of 52 degrees divided by the sine of 77 degrees. When you do work for me, that step is required, y equals is required, and then the last step then would be to you to type this in the calculator and round it to 3 decimal places. So you type it in, use the fraction button on your calculator. Let me get out of the glare here. So the fraction button, 7 times the sine of 52 degrees divided by the sine of 77 degrees. Control Enter gives me that number right there, which I'm going to round to 3 decimal places. So this is 5.661. And that is my rounded off answer. Okay? Let's look at this problem right here. What are the measurements of angle N and the measurement of angle O? So I look at this, I see that nothing is a right triangle. I can see that I have this angle and that opposite side, so I can use the law of sines. This is the other side I'm giving, so I'm going to find the side angle opposite this, which is angle N. So I have to use the N ratio and the M ratio in my setup. So the sine of angle M, which is 70 degrees over 4, equals the sine of angle N over 2. So there's my setup. Here's the space that has the variable. So I'm going to multiply the diagonal and divide by the third number. So the sine of angle N is 2 times the sine of 70 degrees divided by 4. And you can reduce these two numbers here. Never reduce the sine thing. This is not a number 70 here. This is the sine of 70. You don't know that number. Just leave it. But these numbers in front can reduce to 1/2. So this is the sine of 70 degrees divided by 2. Now, notice I don't have angle N here. I have the sine of N. So just like we learned in the last one, I need to use the inverse trig function to get to the N. So multiplying both sides by the sine inverse gives me N is the sine inverse of, and then you type this inside here. That is what N equals. I need this step is required, and this step is required. Most people still have to do this step also, but these are the two values I give points for. Once I have this, then I can use my calculator to approximate this out. And so we type this into the calculator. We type trig sine inverse. The parentheses are there. Put a fraction button. Then type trig the sine of 70 divided by 2. Okay, and then do Control Enter, and I get 28.024 degrees. So there is N. I can use law of sines to find the other one, just like I did this one, but it's a lot easier just to simply do that the measurement of O is 180 minus 70 minus 28.024. And then we can use our calculator to figure all that out. And so O is approximately 81.976 degrees. And there's your two angles. Okay? Here is a problem. So we have a pilot, he's flying from Omaha to Chicago, and we notice that, hey, there's a storm right in my path. Okay, this distance is 471 miles, but I want to fly around this storm. And so the question is how much farther is the route around the storm than it was the direct one? Okay, so never forget what the question is asking you, because the process we have to follow is we have to find this length. I know this length is 471. I know that length is 260. I know these two angles, 148, 15. I need to find this side over here. I'll call this side over here A. So we can use the A value for it. Okay? And so you can see I have a complete ratio right here. So I know that the sine of 148 over 471 must be equal to the sine of 15 degrees over A. Solve for A. So A multiply the diagonal divided by the third is 471 times the sine of 15 degrees all over the sine of 148. And we can use our calculator to approximate that out to 3 decimal places. And so 471 times the sine of 15 over the sine of 148. So A is 230.042. And since everything was in miles, so is this. So the question is, how much farther is the route than the direct route? Well, how much farther? What is the route length? What is this length, this detour length? Well, it's 260 plus this. So the detour is 260 plus 230.042. So you add all this up and you get what, 490? And so how much farther is this route than this one? We'll subtract these two numbers. 490.042 minus 471 is what? So it is 19.042 miles long. That is the answer to your question. Okay? So make sure you always answer the question that is being asked of you. Let's look on the next page. The next page has this question, and it's a standard question, so that's why I wanted to talk about it. It says, solve the triangle. Okay? So what does it mean to solve the triangle? To solve the triangle means to find all the missing side lengths and angle measurements. So if I'm given this problem right here, we can give labels to this. We'll call this A, B, and C. You see that I am missing side A, I'm missing side C, and I'm missing angle B. So I need to find these three pieces of information, given these three pieces of information. And so to do that, we have to use the law of sines. We need a complete ratio, which I don't have. But I can kind of have it because I have these two angles, so I know angle B. So the first thing I want to do is find that angle B is 180 minus the two angles that was given to me. And we get angle B to be a number we can then use in the law of sines. So what is 180 minus 45 minus 65 equal? That one you already know is 70 degrees. So B is 70 degrees, and there is one piece of our information. So because this is now 70, I have a complete ratio. And so I can do the sine of 70 degrees over 26 is equal to, and then I can just pick one of these other ones, the sine of 45 over A. And you just cross multiply and solve for A is 26, the sine of 45 degrees divided by the sine of 70 degrees. And then I can just approximate that out using my calculator. So 26 times the sine of 45 divided by the sine of 70, and I get 19.565. I can do the same thing over here for C. Always use that first ratio. Don't use this number in the second ratio unless you absolutely must. So go back to this one. It's the closest to the cleanest numbers you have. And then I can use the sine of 65 degrees over C. Do the same process, cross multiplication, and C is 26, the sine of 65 divided by the sine of 70. Okay, and so I'll show you a little trick on the calculator here. See, I have everything almost here. The only difference is that 45 is, can't see it. The 45 needs to be a 65. Well, if I do Control and Z, the letter Z down here, Control and Z, it will put me back up into edit mode for the line above. So Control Z, see, I'm now in edit mode. All I have to do is just move this across, change that 4 to a 6, and now I have that typed in without having to do the whole thing again. Control Enter, and I can get side C is 25.076. And there you go. So we have now solved the triangle. Okay, so this is the work you would show me for this kind of a process. All of these steps are required as you solve your work. Okay, so these are the things I look for. So you want to make sure you always have those in your work. All right, so we'll do more together in class, and that ends this video.